moving on to chemical hazards. Chemical hazards we drop into different buckets. So the first one is naturally occurring. So I mentioned mold earlier as a biological hazard. Well, the hazard that the mold creates is technically a chemical hazard. It's a toxin. There are lots of different things out there that could potentially have harmful mold, like peanuts tend to end up with aflatoxins if they're not stored properly, if growing conditions aren't great that season. Corn, fumigants, rice, and grain. Grain in particular can have a toxin from mold called DON, colloquially known as vomitoxin. Yeah. Ochratoxin A on raisins, coffee. Yeah. So lots of good reasons to keep your product from molding. Then allergens are also considered chemical hazards. That's because of the way your body reacts to it is a very quick reaction. Different people react different way to allergies, so it just depends on the person, but it is very critical and something to look out for. Then decomposition byproducts. So when food starts to break down, some of those chemicals can be pretty toxic, like when your potatoes start going bad. Say you leave it out in the sunshine and it starts turning green on the outside, that is actually producing a toxin. You should not eat green potato skin. The next bucket is used in formulation. So we use a lot of food additives in the United States. We have lots of different coloring agents because we like our food to be pretty. And just think of cereal. Cereal is the food I like to pick out when I think about the food that has all the additives. Because basically they take the grain, they strip off the outside and the nutrients, then they grind it up, they add back the nutrient mix they decided was important. Then they add colors, they add sugar, they add preservatives. And then you get something like fabulous Fruit Loops. And it's delicious. So the potential hazard there is adding too much of something. So if I add too much food coloring, it could be a problem. And certain people are affected by certain food colors like red number 40 and yellow. Yellow 5. Preservatives like too many sulfites can give people headaches. There are regulations on how many sulfites can go into a food. They've done studies on BHT, which is a chemical additive they use for cereal to make it crisp, where they found in certain quantities in large consumption that it gave rats or white lab mice cancer. So we have to be careful about how much we use in formulation. That's your control around those. Then intentionally or accidentally present. So unintentionally, incidentally present. We use cleaning and sanitizing chemicals. Those things can accidentally still be, say, on a surface or inside of something, and we accidentally mix the food product into it. Budweiser had an accident where their equipment malfunctioned, and they ended up with caustic cleanser in one of their beers. They didn't know it. So there's this guy, he's drinking Budweiser. 1 beer, just fine. 2 beers, feeling good. 3rd beer, 1 sip, instantly vomits blood because of the caustic cleanser, so it burns up his insides. It's a pretty bad one. Pesticides, herbicides, and fungicides are all things we use in our agricultural system, so we have to be careful about spray and harvesting schedules. So we spray with enough time ahead so that when we harvest it, all those chemicals have gone off. But it is a good reason to actually wash your produce, in addition to the fact that there could be other things on there. Like if I'm picking berries, birds flying through the sky, we could poop on the berry, right? Now you're getting it as a customer. Wash your berry. Wash your berries. What else? Heavy metals. So when you think about something like fish, we know that fish is pretty likely to be contaminated with mercury. So much so that, there's thought as to how much fish is too much, right? So just be careful if you have a heavy fish diet that you pay attention if you're having any neurological symptoms, because it could potentially be heavy metal poisoning from mercury. It also happens from chemicals from the ground. So some foods are really great at bioremediation, which means they clean the ground, right? So they uptake things like heavy metals and pesticides and herbicides from the soil. Great for the soil, bad for you if you're eating it. Peppers are good bioremediators. Mushrooms are good bioremediators. So are hops, marijuana plants, CBD plants. Drug residues, that's specifically for your animals. So if you're a meat eater, when you think about, the livestock, the way we raise them, they tend to all get sick. If one of them gets sick, we use antibiotics on a regular basis to reduce the numbers of microbes and the potential that will pass on to humans. The rules around that is that the antibiotic has to be out of the meat or out of the cow. So out of the meat before slaughter, or out of the cow before it gets milked. So depending on what industry you're in. And Now, in the U.S., we are required by the Food Allergen Labeling Consumer Protection Act to put the 9 major food allergens on our labels. So these allergens affect about 7% of the population. That is 2% of adults and 5% of children. You might notice that it used to be 8. But as of this year, sesame is now also on our list. And so we have to add sesame to our label. Specific rules around this. If I have a different kind of tree nut, right, I have to list the specific type of tree nut, right? If it's coconut, I have to label coconuts. If it's pistachio, I label pistachio. Then for the fish, I have to label the specific kind of fish. So is it salmon? Is it tilapia, right? Same for crustacean shellfish. There are some exceptions to the allergen labeling rule. Exceptions to that warning statement. So if I am selling produce, say I'm in the produce aisle and I'm selling an actual coconut, so you can see the coconut. I do not have to put a warning label on the coconut that says contains coconut, because you can see that it's a coconut. The other exception is if I have highly refined oil, where the protein that would have caused the allergic reaction is processed so much that it doesn't even closely resemble that old protein in shape, right? So it's been denatured, then it doesn't cause that allergic reaction, then I don't have to put it on that label. But that has to be proven, so you have to be careful with that one, with the different oils. So pay attention. Because something like soy lecithin can cause an allergic reaction and would have to go on your label. The way we manage our chemical hazards, we have lots of different methods. Supply chain controls is a big one. So I might be asking for COAs for my produce to make sure they don't have pesticides or toxins or heavy metals. Sanitation controls, making sure that I am cleaning and sanitizing if I have shared equipment for allergens, or that I have things segregated relevant to allergen controls. So I'm segregating my storage areas for the different allergens. So it's really unlikely that I'll have cross contact. Say you have stuff in storage, right? And you have an allergen containing material on top and a non-allergen containing material on bottom. If that bag on top splits open, it can contaminate the bag on the bottom. So pay attention to how you store things, what order you store things, and where you store things. And then process controls around your chemicals and formulation. So paying attention to those weights, or how much of what you're adding to the product at what rate. Physical hazards tend to be pretty straightforward. Metal and glass, pretty common. Metal, when you have metal contact in your equipment, or maybe you're using a metal food container. So a lot of times we'll have metal detectors in place. Plastic is a big one for accidental choking or cutting people. When you think about packaging, right? Something doesn't seal right and you accidentally get a bit of plastic into a product. Or, for example, Kraft had a malfunction in how they do their individually wrapped cheese slices. And so the way it was peeling off, there would still be some left over, and they were worried about it being a choking hazard. Other things like rocks, potentially break somebody's teeth. There was one company that I taught for that made potato salad, and they had to sort through their potatoes for golf balls. That's because their potato grower, their supplier, they were next to a golf course. So when they harvest, the supplier couldn't get the golf balls out. So this company, they literally had to go through, and as they would do their quality check for the potatoes to make sure they weren't given a bad shipment, they would also go through and sort for golf balls. Economically motivated hazards happen for a few different reasons. Sometimes it's competition. So some manufacturers competing with another one, and they intentionally cause harm to the food to ruin their reputation. That happened with two cattle ranchers. They were producing meat cattle and milk cattle, right? And they were feuding. And apparently the wife of one farmer was having a good time with the other one. And so the second farmer decided to poison the cows. Sometimes it's just literally to save money. There was a manufacturer in China that was selling cumin. And in order to save themselves some money, they decided to take peanut shells and grind them up with their cumin to thin out the cumin, save themselves some cash. Well, they sold that to a producer of taco kits. Tacos don't have peanuts in them. So now this manufacturer has an allergen in their product they don't know about. They had a massive recall. That one was particularly terrible. Sometimes it's done to intentionally harm a customer as well as to save money. There's a dog food manufacturer in China that was using melamine in their dog food. That way they could put less protein in it, saving them money. When you test the product in a lab, melamine shows up like it's protein. But it actually can make dogs really sick and can kill them. So usually for these kinds of hazards, it's about supply chain control. That's where those audits are a big deal, and reviewing the paperwork and warning letters and things like that. Corrective actions from your suppliers is huge, and looking at their history. In this section, we looked at chemical, physical, and economically motivated hazards that could potentially affect your products. Anytime you're doing a hazard analysis, you're going to look at these and say, what could potentially be an issue for us? If you find that you have a reasonably likely to occur significant hazard, then you're going to go ahead and put that preventive control in place. And those controls must be documented in your food safety plan. You see that word must there? That means we have to do it. Now we're going to look at the preliminary steps for your food safety plan. The first part is to assemble your food safety team. Now what that means is preferably one person from each department. That is because we are not all-knowing and we need help from other people. Other people in different departments are going to have expertise in their area, and so they'll have a way to broaden our overview. Also, that helps when you go to implement your food safety plan. You have somebody who represents that area who's going to be pushing forward that food safety culture in that specific department. Very helpful. The next part is to describe the product and its distribution. So what are the food safety characteristics about that product? pH levels, water activity, temperature requirements. What are the ingredients? What's the packaging like? Is it reduced oxygen packaging or is there air in there? Do you have to actually have like a seal around it? So lots of different things that go into that. And then distribution. Thinking about the trucks. How clean are the trucks that it's going out on? Things can get easily contaminated on a truck, whether it's chemicals or like allergens. Then does that truck need to be refrigerated? We don't want people doing things like turning off the refrigerator in the truck to save on gas during the transportation and ruining your product. Is it going out on a boat overseas? And if so, does it need to stay dry or does it need to be frozen the entire time? All different considerations of what it's going to need for your product to be safe. The next part is to describe the intended use and consumer. So one, our consumer, are they an at-risk group? Children, elderly, immune-compromised individuals? Or then we look at intended use. So what do we expect our consumer to do with our product, but also what might they do with our product that we don't expect them to do, right? It's not the acceptable use of the product. So for example, cookie dough. I ate cookie dough raw as a kid growing up. It's my favorite thing to eat with movies while I watch movies. You're not supposed to eat cookie dough raw. Now, thankfully, they have cookie dough out in the store that says, hey, you can eat it or you can bake it. And that's just great. So that's an example of somebody where somebody saw the unintended use happening on a regular basis, people eating raw cookie dough. And they're like, all right, we need to make sure that it's safe for people to eat this cookie dough raw. So that means things like taking care of the flour, because flour can be contaminated with E. coli or different microbes, and salmonella from the eggs. So we're pasteurizing these things before they go into the cookie dough. There are lots of different products that have that unintended use issue. For example, the spicing and stuffing packets. Stuffing is intended to be cooked, and it's intended to be cooked like right away as soon as you make it. And those spices, they have not been taken care of properly to ensure that those microbes aren't dead because it's intended to be cooked. And so people put that spice on their popcorn and potentially make themselves sick. Next, we have the flow diagram. So your flow diagram outlines each step of your process in a pretty clear form. You're going to use that to build your food safety plan, to do your hazard analysis. So it's a pretty key piece. And then the last part is to verify your flow diagram. So you're actually walking around your facility to make sure that you didn't miss any steps, because it can happen. So just double check it. When we're getting ready to build our food safety plan, there are lots of places we can go to get our information. First and foremost, your people. Your people have experience, practical knowledge. They know what's going on from working in your facility. You can also bring in experts, consultants. You can submit questions to the FDA or the FSPCA. Publications are great, peer-reviewed publications, right? Studies that have been vetted and verified and redone. Reliable internet sites. Remember, not Wikipedia. We're going for those scholarly articles, right? And then FDA guidance documents, always a great source. When you want to ask a question directly, you can go to either one of these websites and submit a question into the forum. So the FSPCA has their own technical assistance network. It's great. If you have any questions on clarity for regulations, and same with the FDA. So that way, you can get it from the mouths of the people who created it or the people who built this curriculum. And they do actually answer your questions. I've submitted a few myself, and the response time varies. Sometimes it's 1 day, sometimes it's a long time. I have a few examples of different guidance here. We have seafood HACCP and juice HACCP available. And then we do have the Food Safety Preventive Controls for Human Foods Hazard Guidance available to us as well. We also have a great hazard lookup site, which is phenomenal. So once we've done those preliminary steps to our food safety plan, the next step is to do our hazard analysis. And so basically we need to identify those known and reasonably foreseeable, right? So potential hazards that might be associated with our product or our process. Look at how likely it is to be an issue and how severe the consequences are. And then if we decide it requires a preventive control, right? It's severe enough, it's likely enough to happen. Then we identify one of our preventive controls, whether it's process, allergen, sanitation, or supply chain. So if we do a thorough hazard analysis, it's very likely to reduce the risk, focus our efforts, and make sure that we're putting our resources in the right place. And we are required to have a written hazard analysis. Revisiting our definition of a hazard, you remember from before, any biological, chemical, or physical agent that has the potential to cause illness or injury. Now that's our basic hazard definition. We're going to look at what a known or reasonably foreseeable hazard is. And so that's a hazard that has the potential to be associated specifically with facility or with the food. So that's what they mean by that particular language. Yet another hazard definition. So this one is a hazard requiring a preventive control. So when do we have to have a preventive control? If the hazard is known or reasonably foreseeable, like we saw before. And if in your hazard analysis, you decided that it's likely to cause severe illness or injury, then you are required to establish one or more preventive controls, and that you have to put in implementation procedures around that preventive control. So that's that monitoring, corrective actions, verification, validation. Preventive controls are basically the systems you put in place to make sure that when you're making a food product, that hazard doesn't get to your customer. So it's essentially, what do you have to do to make sure you have safe food? And one of the important word choices they use here is significantly minimize or prevent the hazard, right? So it's something to keep in mind. Are we minimizing the hazard or are we eliminating it? Because those are two different scenarios. So now we get to see our hazard analysis form, and we are going to walk through the E.G. Food Company example that you would have looked at in part 1. So as we look at this form, we follow each column and we fill them out. So for the first column, you're going to put in the ingredient and processing step. That you take that from your flow diagram. So you would start at receiving. What are we receiving? Maybe in this example, we were receiving egg. That's what we would put in there. And so you're going to do that for each individual step of your process, for each product and ingredient, when you do a thorough hazard analysis. Just a heads up, for this class, you are not going to be able to do every single step for your hazard analysis. I would say pick 2 to 3 steps and work on those. So you can start from the beginning and go down, or you can choose steps that you think might be a preventive control and follow through with those. So step 2 is to identify any biological, chemical, or physical hazards that might be introduced, increased, or enhanced at that step. Remember BCP, biological, chemical, physical. Part 3. Decide whether or not it requires a preventive control. So you put yes or no here. And remember, this is where we look at the severity and how likely it is to occur. Number 4, we have to justify our decision. So maybe I say, no, I don't need a preventive control because I'm handling it with a prerequisite program or GMPs. Or maybe, no, it's really unlikely to occur. Or maybe it's a yeah, it's really likely that we're going to have salmonella in our eggs. And we definitely need to make sure that we have a kill step in place because people will get sick if they eat salmonella. Now, when you justify this in your hazard analysis for your facility, you're going to look up justifiable scientific information or guidance to back this up. The next column, number 5, what preventive controls can be applied to prevent the food safety hazard? In this case, you identify whether it's an process, allergen, sanitation, or supply chain control. And you say, okay, what is that control going to be? Now we know what type it is. Then you look at, okay, we know what that control is. Is it going to be applied at this step? And you decide yes or no based on the step that you're working at. So for example, if I were getting a label in and I needed to check and make sure that the allergen was present on the label, this is my receiving step, I would say, yeah, I absolutely check to make sure that the allergen is present on the label at my receiving step that is an allergen preventive control. Now we get to go through E.g. Food Company's example, and you can look at this entire thing in Appendix 3. The hazard analysis starts on page 9. It's all the introductory stuff before that if you would like to check it out. So for their first step, receiving packaging, they looked at what potential hazards there might be. And they're like, oh, undeclared allergens. They have egg, milk, soy, and then they have wheat in their biscuit omelet. So these are the omelets that you get at like those hotels where it's just like literally folded egg or folded egg with cheese. And in this case, there's also one with a biscuit. So they decided that it does require a preventive control because their label carton has to have that allergen declaration present. And so it is an allergen control where they review the label for the allergen when they receive it. So yes, it happens at that receiving step. The next one is receiving shelf-stable ingredients, and they're getting the pan-release oil. Now, this pan-release oil has soy in it, so that's an allergen. So they decided it does have to have a preventive control because the soy lecithin may have that soy allergen. They know that cross-contact isn't an issue because it's in every single product, just like egg and milk is in every single product. However, they do need to have it on the label. And in this case, they know that it's going on the label at their specific labeling step. So they're going to do the check for the labeling process. So what they'll do is they'll do a check when they first start the run, anytime they have a label changeover, and at the finish of the run. And that should account for making sure the right label's on the right product. And then it lists soy. Okay, so now we have receiving refrigerated ingredients. This is liquid pasteurized egg. They're worried about salmonella as a biological hazard, and we have egg as an allergen. Yes, for preventive controls for both of those. Now, in this case, they cited their own data from their facility for the reasoning behind why they need to have a preventive control, because they're getting pasteurized egg. So it seems less likely that salmonella would be in there. But in this facility, they found that salmonella does occasionally occur. And they do have a control for this because they're cooking the egg. So they have a process control at a cooking step. Since we're at refrigerating, that doesn't happen here. So it's a no that it's not applied at this step. Then for the allergen, again, we're just checking the label at the labeling step to make sure the egg is on the label. This next part is about receiving milk. So they're getting pasteurized milk, and it's almost exactly the same as the egg where you're worried about pathogens, you're worried about allergen. They have a cook step to control it, and they have a label step to control for the allergen. So neither of those happen at this receiving step, but they are identifying them. The next one is a little different. So they're receiving their pasteurized processed cheese. And this cheese never gets cooked in their product. So their product is considered ready to eat, and it's frozen. So it's a little bit odd. But basically, the idea is that It is processed enough that the customer could put the frozen omelet into the refrigerator to defrost it and then eat it without heating it up. So the heating step is just for taste, which is kind of weird, but it's the way they wrote it. So it's a ready-to-eat product. That means that the cheese never goes through a kill step. The cheese never gets cooked. The egg gets cooked, the cheese gets slid in with the egg. And so they have no kill step for the cheese. So in this case, they're worried about vegetative and spore-forming pathogens, Salmonella, E. coli, L. mono, and CBOT. They do require a preventive hazard, and their justification, they cited ICMSF in processed cheese, that the hazards need to be controlled. So they needed to be controlled from the supplier, since EG Food Company doesn't have a control for this step and their customer is not necessarily cooking their product, then the person that needs to have the control in place is the supplier. So the cheesemaker is the one that has to control for those hazards. So we use the supply chain control, which means third-party audits and checking up on their records and all sorts of things that we'll review when we get to the supply chain control part. So since we're at receiving, it's going to be a yes at this step, because what we're going to be doing is we're going to be checking the documentation that comes in with the cheese to make sure, yes, it came from the right processor. We get the certificate of analysis that says, there were no pathogens that they found. And then the second hazard you see here is a chemical hazard for milk as an allergen. And again, milk isn't everything, so they don't have to worry about cross-contact, but it does have to be on the label, and that happens at a subsequent step. Then we have receiving our frozen biscuits. This is our unique allergen, wheat, and in this case, we have to be careful about cross-contact because it is only in one product. So we have two controls here. One, an allergen control because of the label, and two, we have to prevent cross-contact. What that means is they have scheduling. So the order of cleaning, it goes the plain egg, the cheese egg, and then the one with the wheat biscuit at the very end. And then they do a nice big thorough cleaning after that last one to prevent the likelihood of it contaminating when they start production again. Next, we have our fill away label step. And they've decided that allergens, of course, are going to be a key here because we have that label going on. They need to make sure that the proper label is on each product. So that's a huge one. Now we've made it to your hazard analysis exercise. This one can be a challenge. I would suggest limiting yourself to 45 minutes for this one, just to make it more manageable. And what you're going to do is you're going to pick one of the example food safety plans. So we have a whole bunch of them available to you. Pick your favorite one. You're going to review the introduction to that food safety plan. Then you're going to look at the flow diagram, and you're going to pick out each ingredient and each step of the flow diagram. And you're going to pick 2 or 3 steps, no more than 2 or 3 steps. And you're going to do the hazard analysis for those 2 or 3 steps. And so you're going to say, all right, as we go through this step, we're going to answer each question under each column as we go across the row. So we're going to identify the hazards. We're going to justify whether or not they are significant hazard and they require a preventive control. If they do, we're going to justify our reasoning first. And then if they do require preventive control, we say what the preventive control is going to be. And then we decide whether or not it's applied at that step. Okay? So that's a lot. There are instructions on the hazard analysis form. There are also a lot of resources for you to be able to look up those hazards. And I have a link for you to the FDA hazard lookup, which is really nice. And you should be able to move through with your hazard analysis. Happy researching.